Hi, my name is Muhammad Ibrahim Zulkifli. My metric number was 122251018. Today, I will explain about our problem statement. The main problem is a traditional security system, such as lock and gates cannot provide early warning against inter- intruders. Their residents are awake. Most homeowners are awareness of suspicious activities around their properties until it's too late. This project proposed an intruder detector system that can identify unauthorized access and send immediately notification to the user. The ensure home safety, and minimize property damage. For the objective, first to design and simulate a intruder detector system using PIC ATF F45540 in Proteus. The second one, to deliver a CCS programming that detect unconscious movement using a motion sensor, PIR sensor, and display the system status on an LCD. Another next one, to implement an automatic alert system using LED and buzzer when intruder is detected. And the last one, to verify and fungibility of the intruder detector system through simulation and hardware testing on a PTK48 training board.
Hi, my name is Nabi Fitri bin Nasruddin. My metric number B122510203. Next, I will present about system overview. The intruder detector system continuously monitor the surrounding area using a PIR sensor. The sensor sends motion signal to PIC 18 F4550 microcontroller, which process the input and control the output device. When movement is detected, the LCD display intruder alert while the LED and buzzer are activated. If no movement is detected, the LCD display system secure and alarm remain off.
My name is Muhammad Malaki bin Muhammad Nazim. My metric number is B122510191. Why PIR sensor? Sensor selection. The PIR sensor was selected because it is inexpensive, consuming low power, and is easy interface with the PIC 18F4550. It provides fast motion detection, making it suitable for indoor security application. However, it can only detect movement and cannot measure the exact distance between the sensor and the object. System operation. The system that using the microcontroller and all peripheral device. The PIR sensor continuously monitor the surrounding area. If motion is detected, the LED and the buzzer are activated while the LCD display intruder alert. Otherwise, the system remains in monitoring mode and display system secure.
We go to the next page. Market strategy. Target market. Homeowner, individuals seeking of affordable and reliable security solution to protect their home from unauthorized disruption. Resident communities, communities, apartments, and residential area they require additional security monitoring for common entrance and district zone. Small business and retail shop, small commercial premise that need simple illusion detection system and safeguard asset during non-operating hour. We go to the next page, value proposition, real-time intruder detection. Utilities motion sensor to instantly detect unauthorized movement within the protect area. Immediate audio-visual alert. Activate LEDs and buzzer alarm immediately upon instruction detection, allowing quick response to potential threat. Cost-effective security solution provide essential home security function at a significantly lower cost compared to advanced commercial security system. We go to the next. Microcontroller-based automations deploys the PIC 18 F4550 microcontroller for reliable operation, making the system suitable for educational, residential, and small business application. Easy installation and operation. Designed with a user-friendly and interference and straightforward setup, requiring minimal technical practice. Scalable design can be expanded with additional sensor, DSM module, or IoT feature for internet security monitoring and remote notification.
Next, for the coding, section 1, initialize and hardware mapping, line 1 until 32. Zoom in the one first column of code from the coding. Looking at the first section of our code, we establish our hardware foundation. We include the register definition for the PIC 18F4550 and configure our device fuses, specifying a high-speed external oscillator clock at 20 MHz. We also include the flat LCD.C driver to manage our peripheral display. Next, in the line 7 through 9, we explicitly define our hardware mapping. Pin B3 driver our lamp alarm LED. Pin B2 control our buzzer alert, and pin A0 is assigned as our sensor signal interface. Inside the main function, we initialize the LCD and configure the input-output port. On setup, the system clear the peripheral and output a brief into the system or system ready. Message to the screen for 1.5 seconds establish a secure baseline before entering the main loop. For the section 2, sensor interfacing a signal timing, line 33 until 70. Zoom in on the middle column of code from the image. Once inside the execute loop, firmware continuously interact with the ultrasonic sensor. To trigger a reading, we set pin A0 as an output, put it high for a precise 10 microsecond plus, and put it low again to generate the sonic burst. We immediately switch port A to input to listen for the echo. To ensure the microcontroller doesn't hang indefinitely waiting for a return plus, I implemented timeout protection using timer 1. If the signal doesn't transition with 16,000 timer tick, the loop safely break. Once the echo plus arrive, timer record it exact width. Using the speed of sound and our clock frequency, we convert this raw duration into centimeter by multiplying the timer value by a calibrate scalar of 0.0272. For the last section, threshold evolution and system action, line 71 until 95. Finally, the microcontroller evaluate the process distance against our safety threshold. As seen in line 72, if the detected distance fall between our critical zone greater than or equal to 0.2 centimeter and less than or equal to 10.0 centimeter, the firmware flag an active trait. It pull the LED and buzzer pin high and print a high priority into the alert. Warning to the LCD displaying the exact target distance. Conversely, if the distance fall outside this window, the system enter its L branch. The alarm are deactivated and the LCD display system secure a 300 millisecond delay conclude each iteration to prevent display flickering and stabilize answer polling. The architecture ensure a highly response, deterministic, and safety embedded application suitable for localized security monitoring. Next, for simulation result. The simulation successfully demonstrate two operating conditions. Normal condition, LCD display system secure, LED off, buzzer off, intruder detector, LCD display intruder alert, LED on, buzzer on. This result confirmed that the software operated according to the product requirement.
For this slide, we show about simulation result software we use purchase for the simulation. We can look on the left side. We have uh, when below 10 cm, uh, the LCD will show into the LED, and the LED will appear, and the buzzer will sound it, and on the right side LCD shows secure. When the when upper than 10 cm, and LED will not appear and buzzer will not sound. This is the simulation result on the hardware, and the LCD will show into the LED. And after we can look at before, then now have interior LED, and after we have the interior LED.
Hello, my name is Mariam Afza binti Mazlan, and my matrix number is B122510204. First, feature improvement. To improve the system, several adjustments can be considered. First, integrate IoT technology using ESP8266 or ESP32 for smartphone notification. Second, add multiple sensor to increase the monitoring area. Third, install a camera module to capture image during instruction. And last one is include the rechargeable battery backup to ensure the continued operation during power outage. The last slide is conclusion. In conclusion, the intruder detection system for home was successfully designed and developed using the PIC 1854550 microcontroller. The system is capable of detecting unauthorized movement through a motion sensor and providing immediate alert using LED and buzzer. The implementation of this system ensures home security by enabling yearly detection of potential intruder and allow homeowner to respond quickly to security threat. The project was successfully verified through simulation and hardware testing, demonstrating reliable operation and effective as a low-cost and practical home solution. Furthermore, the system can be expanded with additional features as GSM or IoT-based notification for improvement functionality in future development.